There are three distinct forms of hibernation that occur in response to cold, short days or lack of food. The first one we will consider is classical or really serious hibernators. These are animals such as ground squirrels, marmots, echidna, and these hamsters. These hamsters have a body temperature of 37 degrees Celsius and a heart rate of about 400 beats per minute. They are physiologically just like you or me, just a lot smaller, and hence the heart rate is much higher. This hamster has been hibernating for 100 hours and has a body temperature of 5 degrees Celsius and a heart rate of 10 beats per minute. During hibernation, energy use is minimized so that no proteins are made and cells cannot divide. Some of the connections in his brain have regressed. His brain makes no brain waves, so by human standards he is brain dead. He cannot hear or move or see, but he can feel vibrations and monitor air temperature. If he is not touched, he will stay hibernating for about a week, then he will spontaneously rewarm to 37 degrees Celsius and stay at this interbout temperature for about 12 hours before re-entering hibernation. This cycle is repeated for the duration of the winter. If he is touched, activation of his sympathetic nervous system coordinates his return from wherever he is to the space-time continuum we recognize. To rewarm uses a lot of energy making heat, and at 4 degrees C, complete arousal takes about 3 hours. In this bright room at unnaturally warm 25 degrees C, it still takes more than an hour. In the early stages of arousal, the only thing you notice is that respiration rate and depth increase. This results because, although you would not suspect it, under his skin he is performing a number of remarkable physiological feats that require a lot of oxygen for his cellular work. Attaching a radioactive label to his red blood cells allows us to image the hamster's blood flow and volume during the early stages of arousal. This reveals a masterly display of vascular control that humans will never achieve, whereby the hamster orchestrates, via strong vasoconstriction of blood vessels below the diaphragm, to decrease the amount of blood in the lower body, as blood warmed by the heart and brown adipose tissue is kept in the head and neck regions. In this way, more important organs, such as the brain and heart, are warmed much faster than the intestines and hind limbs. In the middle stages of arousal, the muscles in the head and neck have warmed up enough to generate heat by shivering, and so he shivers a lot, and his top half gets hot, just as we do with isometric exercise. The last stage of warming involves the release of hot blood in the head and chest into the colder legs and intestine. As yet, incomplete regeneration of neural connections, coupled with colder hind limbs, means that he is unable to perform simple motor tasks for about 20 minutes after he arouses. In this time, he appears to rest, and his brain regenerates synaptic connections. His now recordable brainwaves look similar to those recorded during sleep. In the next 12 hours, he will eat and drink a little, rebuild his nest, and tidy up his cage before re-entering the next bout of hibernation.